This analysis, this tutorial is about COVID-19 analysis, and so this is an extraction of the code from what I've been doing to understand the COVID spread for myself. So the code just I have been working, and we'll just show you now, is this one, where you basically can see that I needed to get data from different data sources. The first data source I use is the World Health Observatory, and as well as also the population data from the UN server. And as well, I needed also to get some of the COVID cases data from the John Hopkins. So I'm just scrolling to show you just the different things that you can do. So from the John Hopkins server, which is one of the most up-to-date data for all the countries in the world. So I give you, so the first part that I ask you to do is first, of course, to understand the code. To understand, and the first part of this challenge is about understanding how to get health related data from the WHO Health Observatory using API. Because you have very short time, I don't ask you to write that wrapper, so I wrote for you, and here you have. So for example, just a tip, these are just helpers, and the main wrapper is the WHO API code here. Everything is working and you don't have to do anything. It's basically just you need to just understand the code and write. So to understand, if you need to understand about the type of data that we are getting from the WHO Health Observatory, I give you reference here so that you can go and check. So the first challenge I ask you is that I have produced this plot, which is very useful, and this is for me comparing the Ethiopian data to the Italian data, for example, and this is the age group, and this is the probability of dying that in that country. So this is inferred, like it is a really high quality data, that this is from 2016, that the WHO and the Ministry of Health of Ethiopia, or each country, in this case if you are in your country, the Ministry of Health of your country and WHO work together with all the data that is available and produce this very valuable. So this tells you the probability of dying at age, at this specified age. So I give you just a kind of plot that I want you to produce, and also a hint how you can produce it, so or how you can produce it. All these descriptions, and also here I just start a starting code where just basically you don't need to do anything. The data is fetched actually using this call, dying probability. You can just look at the data, and what I ask you is just to change this part for your own country and for the countries you want to compare, and then basically reproduce this type of plot for your country. And in challenge 2, I just basically it's gonna be the same, but now I want you to call the days rate class method here. Country data, this is the days rate data. I want you to call that one and again produce plot. So for challenge 3, I'm giving you again a way how you call that part. This is about the probability. It's a probability of percentage of dying between age 13 and age 70, just exact age 70, from any of these cardiovascular, cancer, diabetes, or chronic. As you may know, these are the most important comorbidities that are, if you have those, if a person has this disease, they are more likely to die from COVID. So that's why we need to get that kind of data for your country. So again, you can use this one from the WHO server, and you can plot and compare your country with respect to any other country. So the next analysis we need to do is to get data for COVID, actually the case data as a function of time. And again here I don't ask you to write all the code. I wrote a class here and a wrapper, such that you basically have to provide to call this class and call the one of them to search for your country. Again, as a use case here, the kind of plot I will want you to produce is that I want you to compare your country with respect to your neighboring countries. So in this case for Ethiopia, I'm using, so Ethiopia has 5 neighbors, and I am comparing the 5 countries with respect to Ethiopia. In this case only for the positive cases, but I expect you to do the similar plot, because the code gives you the 3, the number of positive cases, number of dead, and number of recovered at each day. And I want you to close this, and I also encourage you to do more. So once you do that, what I really like you to do is that once you produce a nice plot, I want you to go to your Twitter account and share that kind of plot using a hashtag 10 Academy COVID-19 response, such that we can collect and the link to your tweets, I want you to include it in your challenge, as well as also otherwise also when you submit the code, you can add the different links to your tweets into the note, and that way I can see your plots just from Twitter, and as well as also it's a way of telling other people how your country compares with the neighboring countries. So here I give you example and also kind of hint how you can transform the data into a dashboard. So it's basically straightforward, but just only you need to understand the code. Okay, so this is it for now. And I also provided a solution, working basically for the Twitter challenge. In the same folder you have, now you will get a Twitter challenge solution that basically solves all the errors, so that you can actually just once you have the developer account, you basically can download and filter and do everything. So it doesn't have error anymore, the first code. I still didn't provide the 3 solutions, but that should be straightforward. You should just play on that. Okay, so good luck. And this is probably one of the exciting one, because whatever you produce from this tutorial, you can use it to impact, like to understand your country better, as well as also to share to your friends, your family, and others about the state of COVID in your country or in your neighboring countries. Okay.